Okay, so let's look at the conditions. We just looked at this example. I'll just say this kind of quickly. Okay? Is this going to give us a slant asymptote? Well, if we divide this into this, what's the highest power of x that we're going to get? It's got to be x cubed. If you do the long division, if you had an x cubed here and divide the x into that, you're going to have an, if you had an x to the fourth here, you'd have to have an x cubed here to multiply by the x to the fourth to match it up, right? And why is that? Well, it's because whatever you get, whatever this is equal to, if it doesn't have an x cubed, well, whatever it has over here multiplied by this has to equal this, right? If you don't have an x cubed over here to multiply by this x, there ain't no way you're getting an x to the fourth. Plain and simple. And if you've done, at least a couple of the problems that I assigned, hopefully all of them, and done the check like I asked you to, you understand that. If you haven't done it yet, well, maybe you're going to have to go back and look at the video for that incredibly lucid explanation I just gave you, right? Yeah, you're not even smiling, you just look depressed. Okay, that's all right. That's all right. It's not that you deserve to be depressed, but it's understandable since the long division is probably totally new to you 2 days ago. Okay? Still. Okay. Well, what about this one? What's going to happen if you do this long division? Well, anything you multiply by this to get this, it's going to have a 1 over x in it. An x to the negative 1, so multiply by the x to the fifth to give you an x to the fourth, right? Okay, well that means you're not going to get a polynomial out of this. So you really can't do a long division. Okay? So because of what I just said, long division won't work. Okay, what if you had the reciprocal of this? Let's just say you got x to the fifth plus 3x cubed minus 5 over x to the fourth minus 7x minus 9. Okay, what's a long division going to give you there?
X.
Yeah, you're going to have an x. The highest power of x you need is just the first power. You have an x over here. When you multiply it by the x to the fourth, you'll get your x to the fifth, right? And you can't have anything with power higher than 1. If you had an x squared over here, when you multiply it by x to the fourth, you'd get an x to the sixth. Can't be, right? So this has to equal x plus some other stuff. Make sense? And if it equals x plus some other stuff, then it's going to be linear, right? Okay, so what's the condition? When you look at this, how are you going to decide whether you're going to get a linear, a slant asymptote, a linear function plus something like this?
For highest power being x?
Yeah, the highest power you get here has to be x, right? So how would you look at this and determine whether the highest power is going to be x? Well, you just think of dividing this one into this one and it tells you, right? But we can also come up with a rule that totally obscures any reasoning. And since you're probably going to see the rule, I'll tell you. It says that the degree you get a slant asymptote. I'm using a word here that I haven't really used much. What do I mean by the degree of the numerator?
Exponent for x.
The what?
The exponent.
The what?
The exponent for x.
Biggest exponent for x, right? Yeah, the biggest power of x you have in the numerator is your degree. The biggest power of x that you have in a polynomial is the degree of the polynomial, okay? So we're going to be using that terminology to classify things, okay? So the degree of the numerator is 5. The degree of the denominator is 4. And 5 is 1 bigger than 4. So we get the slant asymptote, right? Does halfway make sense? Now you've got the rule and you got the reason for the rule. Okay, it's not a hard rule to remember if you practice it. But if you understand the reason for the rule, which you probably do or will once you get a little better with long division, it's much easier to understand why this happens if you know that rule. And this example kind of shows you what happens. Okay? Now if this was, if we had this, you'd have to graph this polynomial and this polynomial if you wanted to divide them, or you'd have to divide it out and get this thing, and then you'd have to graph something with a 4th degree denominator, which would probably be a pain. Okay? So I probably wouldn't ask you to actually do, well, I probably wouldn't ask you to graph the function that you have the remainder over the denominator. Okay, the function like this, because the denominator being 4th degree polynomial, that'd be hard to graph. Okay? But you still understand that if x is big enough, this is going to get really big. The denominator of the term that's analogous to this one would get really small, and you'd still have an asymptote to whatever you got here, right? Okay? So hopefully you understand that. Naturally, I'll give you some problems that kind of lead you through it.